6-1 in Advanced Algebra 2. Today talking about functions, arithmetic operations. Those, of course, are adding, subtracting, multiplying, and dividing. Right? We're just going to do those with some functions to start out with. So very complicated. I don't care if you look at it or not. Before we can even get started, though, we need to refresh our memory on like the domain of a function. So this is just like some warm-ups. When you want to find the domain of a function, you don't have to write any of these down. We'll just watch. When you want to find the domain of a function, and it's not like graphed for you already, there's two main concepts before you get into some serious stuff. The domain is what can x be? Well, there's two major concepts. You know, the rule number one in math is you're not supposed to divide by 0. So if you see x's in the denominator of a fraction, that's a bad situation. You're going to have some numbers that don't work. Like, for example, if you had this, f of x equals 3 over x, since x is downstairs in the denominator, are there any numbers that you could put in for x that would give you 0 in the denominator? Like, if x was 1, wouldn't you be okay? If x was 1,000,000, wouldn't you be okay? What number can't go in for x? X can't be 0, right? So out of all the numbers in the world that you could pick, if x was 0, we'd be in bad shape, right? So the domain on this is like x can't be 0. It's like all real numbers except for x equal to 0. So we just say x cannot equal 0. The other rule is you can't take the square root of a negative number, okay? So let's look at these 4 that I have right here. Let's see what the domain would be. This guy. First question that you should ask yourself, do you see any x's in the denominator of a fraction? No. Do you see any square root symbols at all? Pretty good clue then that x could be anything you want it to be, right? Any real number works. You could put anything you want to in there and x is good. So all real numbers is basically the domain in this guy. This guy, do you see any x's in the denominator? No. Do you see any square root symbols? Not squared, any square root symbols? No. So what could x be? Anything you want it to be, right? Anything you want it to be, all real numbers. Here, do you see any x's in the denominator? Nope. Do you see any square root symbols? So what could x be? Anything you want it to be. Here. There's no x's whatsoever in there. People are like, well, there's an f of x. Does an f of x also mean y? So like if I graph this, does anybody remember what that would look like? It'd be what? So would it be horizontal, vertical, or oblique? It would be a horizontal line. So like here's your axis, it would be this. Tell me what the domain of that is. From left to right. Isn't it all real numbers, right? So it again falls under the same set of rules. Do you see any x's in the denominator? No. Do you see any square root symbols? No. Next set. This function. Do you see any x's in the denominator? Yes, right here. So you've got to look at that denominator and figure out what would make it 0. Take the denominator, whatever it is, and set it equal to 0 and solve for x. Done, right? Doesn't this one, if x was 0, wouldn't that be bad? Right? If x was 0, this would be bad. So that means that this is the bad number. X cannot equal 0 is the domain. It's all real numbers except for x equaling 0. So we just write it like this. Check out this guy. Are there any x's in the denominator? Yes. This is the entire denominator. Set it equal to 0 because that's what we can't let x equal, right? So solve for x. What would you get when you solve for x? X equals -1 because if you put -1 in for x, wouldn't that give you a denominator of 0? So what out of all the numbers in the world that you could pick for x, what is the number that you can't pick for x? You can't be -1. So it's almost like you'd say this. instead of saying x plus 1 could equal 0, you could say x plus 1 cannot equal 0 and solve for x. You know what I mean? And x cannot equal negative 1. Ooh, this guy. Are there x's in the denominator? So I want to say this. X squared minus 9 cannot equal 0. Correct? Solve for x squared. Right? And then what would you do to solve for x? Square root both sides. What's the square root of 9? Is it just 3? Plus or minus 3? Because if you put 3 in here, wouldn't you get 9 minus 9, which is 0? If you put negative 3 in here, wouldn't you still get 9 minus 9 equals 0? There are two numbers that do not work for the domain. X cannot equal 3 or negative 3. Cool? How about this guy? Are there x's in the denominator? Yes or no? There's also some x's in the numerator. Nobody cares about the numerator. I should have mentioned that up here. The rule is you can't divide by 0. Nobody cares about the numerator. It's the denominator. So, what would x have to be? Add 50 to both sides. Then what would you do? Divide by 2. And square root, what can x not equal? 5 or negative 5. If you put a 5 in there, this would turn out to be 0. If you put a negative 5 in there, wouldn't it also turn out to be 0? Boom. Number 9. Are there x's in the denominator? So, it's in what we call factored form already, though, baby. What value of x would make that turn out to be 0? If x was negative 1. So that tells you that x cannot equal negative 1. Or, how about this guy right here? What can x not equal? 4. Right? Those are the bad numbers. Every other number for x works. You can't put negative 1 in. You can't put 4 in because you'd get 0 in the denominator if you did that. And that's a bad thing. So over here, are there x's in the denominator? Nobody cares about the numerator. Are there x's in the denominator? What value of x doesn't work? X can't equal negative 1 or 7 halves. You okay with that? And down here, what's the domain of this guy? Let's check the two rules. Number 1, are there x's in the denominator? Nope. Are there any square root symbols? So what numbers can I use for x? This is all reals. These two things passed. There's no problems down here, right? No problems. Next. First, are there x's in the denominator of a fraction? In the denominator? No. Are there any square root symbols? So what you have to say is you can't take the square root of a negative number. Take what's called the radicand, the number underneath the radical, and say, hey, you have to be greater than or equal to 0. It can't be negative. Right? 0 is okay, and anything bigger than 0, and solve for x, right? And solve for x. Done. What's the domain? Any x value that is greater than or equal to 0. And if you put that in interval notation, 0 counts to infinity, right? 0 to infinity. Here, you've got a radical. Take this guy and say, I need you to be greater than or equal to 0. Right? Because you can only take the square root of positive things or 0 and solve for x. What would you do? Subtract 5. So what's the domain? Any x value that is greater than or equal to negative 5. So let's pick one. How about negative 2? Is negative 2 greater than or equal to negative 5? If you put negative 2 in here, you get negative 2 plus 5, which is 3. Can you take the square root of 3? It doesn't come out nice, but can you do it? Yes, right? If I put, let's say, negative 10 in here, if I put negative 10 in here, it's not going to work because negative 10 plus 5 is negative 5, right? And you can't take the square root of a negative number in the real number system. Sure, we've been doing imaginary numbers, but it doesn't work for functions. You've got to stay in the real number system. Here, right? Take that, and what do you want him to be? Greater than or equal to 0. Start solving for x. 2x greater than or equal to 8. X has to be greater than or equal to 4. That's your domain right there. Any x value that is greater than or equal to 4. Finally, let's get started. They want us to do these 4 operations on these functions. So they gave me 2 functions, f of x and g of x. What are they asking you to do with those 2 functions right here? Add them, multiply them, subtract them, or divide them? Add them. Here's the first thing you should do before you get started. Look at the original functions and state any restrictions in their domain. It's basically, please find the domain. Red guy, what's his domain? Is there any bad dudes in there? Are there any x's in the denominator? Are there any square root symbols? Yes or no? So what's his domain? So I put that above there. He's cool. Anything I want to works for x in that function. How about this guy? Are there any x's in the denominator? Nope. Are there any square root symbols? Nope. All real numbers. There are no restrictions in my domain. That means there's no bad numbers that we can put in for x. Back here, these were like restrictions in the domain. It's any x you want to that's restricted to numbers greater than or equal to 0. We restricted the domain. So these are good. Let's add them together. Take the red one, x squared plus 6x plus 8, and add it to the blue one, x squared minus 4. You're just adding the red one plus the blue one because that's what they're asking you to do. You combine like terms in this one. Wouldn't that be 2x squared plus 6x and then plus 4? Y'all cool with that? Adding, piece of cake. All right, piece of cake. Subtracting, not as easy as you think it would be, but once we do a few of them, it's not that bad. You got to take, in order that they show you, doesn't f come first and g come second, take f, which is the red one, and subtract away, watch this, subtract away the entire blue one. So the entire blue one, sorry I wrote it in green though, the entire blue one has to be quantified because you want to subtract that whole thing away, and don't you need to distribute the negative through before you can deal with that. So this is really x squared plus 6x plus 8 minus x squared plus 4. The shortcut is when you're subtracting this one away, don't you just change all the signs on this one right away? Right? You just call that minus x squared and plus 4. Now combine like terms. X squared minus x squared is nothing. 6x plus 12. Rock and roll? Okay with that? That's subtracting them. Watch your signs. You subtract away the second one, all the signs change in that second guy. What do they want you to do here? Notice this. What does that mean? Multiply. That's a closed dot. Right? Just come back to that later. But that's a closed dot. That does mean multiply them together. So let's take f, and you got to put them in parentheses, and take him times g, and he's got to be in parentheses. Parentheses matter. You got to take the whole red thing times the whole blue thing, and you know how to do that. We did that last chapter. So every red dude times every blue dude individually. So that would be x to the 4th minus 4x squared plus 6x cubed minus 24x plus 8x squared minus 32. Right? And then you combine your like terms. Put them in standard form also, highest degree to lowest degree when you rewrite them. So x to the 4th, then x cubed, x squared, here's a couple of them, a total of 4 of them, minus 24x minus 32. That's a piece of cake, friends. Add, subtract, multiply. No problems with those. But what's the next thing? divide them. We're going to have problems. Because, first, let's write it the way they want, f divided by g. What's f? It's x squared plus 6x plus 8, right? And we're going to divide that by x squared minus 4. We now have problems. Why do we have problems? We've got x's in the denominator. So first of all, he was cool by himself. Every x value worked by himself, all reals. But when we put him in here, now we've got problems because we're taking a function divided by another function. Can you tell me what x can't equal in this one? What numbers for x don't work? And if you don't know, you take this denominator and set him not equal to 0 off to the side and solve for x. What are numbers or a number that doesn't work for x? 2 or negative 2. Those numbers are restrictions in my domain. They need to go in the answer blank. Because that's what this says up here. It says indicate any restrictions in the domain. So we will have an answer, and then here's some restrictions. I already know that x can't equal 2 or negative 2 in this guy because I've got x's in the denominator. So far, so good. And now, for your favorite part, we need to simplify this. It's called factoring. Can the red guy, which is upstairs, factor any further? Let's talk ourselves through the factoring cheat sheet, which we may have forgot. Rule number 1, looking at the red thing only. Are there any GCFs that can come out? Nope. How many terms are there? 2 terms, 3 terms, or 4 or more terms? 3 terms. So that's in the trinomial situation. First question in the trinomial category is that a perfect square trinomial? Is the first term a perfect square, the last term a perfect square, and the middle guy twice the product of those square roots? Is the red thing a perfect square trinomial? What do you think? Is it a perfect square trinomial? Is the first term a perfect square? Yes. Is the last term a perfect square? Is 8 a perfect square? So it's not a perfect square trinomial. A value is 1. So you're looking for 2 numbers that multiply together to be 8 and add together to be 6. Can you find 2 numbers that multiply together to be 8 and add together to be 6? What are they? 2 and 4, right? So this red guy, I'm going to start a new line down here, can factor to be what? How could I rewrite this red guy? X, what is this, a plus 2 or a minus 2? So plus 2 times x plus 4. This thing and this thing are identical. So far, so good. Bottom guy, I wonder if that can factor. It's x squared minus 4. 2 terms, correct? Is there a GCF that can come out before I get started? No. After that, when there's 2 terms, there's only 3 things it could be: a difference of squares, a difference of cubes, or a sum of cubes. Is the blue thing any of those things? It is a difference of squares. Factor it. Let's see what you remember. How does difference of squares factor? And I know that your brain is just freaking out on you right now. It factors into conjugates of the square roots. You got an x plus 2 and you got an x minus 2. It doesn't matter what order they're in. Cool. As I said, factoring coming back to haunt us. Well, what's so great about writing the fraction like this? Because look upstairs and downstairs. Is there anything the same upstairs and downstairs? Guess what happens to those? They cancel each other out. So what does this simplify to be? X plus 4 over x minus 2. But the restrictions, you have to do that before you factor anything out. you have to look at what makes the original denominator 0. 2 or negative 2 is a bad situation. And people are like, hey man, if you put negative 2 in here now, you get a negative 4 in the denominator. It's not bad. But it was bad originally because before you simplified stuff, you couldn't put negative 2 into the denominator in the first place. Whew, that's only one example. Let's try it again. 3 things that are pretty darn easy is add, subtract, and multiply. Oh, wait. We better take a look at these guys first. Let's start with red, since that's what I did before. Red guy. Any restrictions in his domain? You're looking for, are you dividing by, or is there an x in the denominator, or is there any square root symbols? What do you think? Any restrictions? All reals. Blue guy. Are there any restrictions in that domain? You're dividing by an x. Isn't there an x in the denominator? So what can't x equal, baby? X cannot equal 0. That's already a problem for us. What that means is, in every single one of these parts, A, B, C, and D, you already know that x can't be 0. So go to the answer blank and put that. It can't happen. There's no way, dog, because it doesn't work for the g function. X cannot equal 0. Cool. Part A, let's add them together. I'll take f with a pen, which is 5x squared, and add it to 2 over x. Right? That's all you can do. Those are not like terms. Remember, 2 over x is like 2x to the negative first power. You can't add them together. So he's done. 5x squared plus 2 over x. And we know that x can't equal 0. That's a restriction in the domain. So let's subtract them from each other. 5x squared minus 2 over x. That's as cleaned up as it can get. Right? There's nothing to do. So nice, nice, nice. So far, so good. But we also originally knew that x can't equal 0. See, we got x downstairs. That's bad news. We can't have x be in 0. It doesn't work for this function. What does this mean again? Not trying to insult you. That means multiply, because that dot is closed, right? That dot is closed. That means multiply. Let's take f, which is 5x squared times 2 over x. Cool? Since 2 over x is a fraction, make 5x squared a fraction by putting them over 1. And we can multiply. You can multiply anything together, right? You can always go further. So, numerator times numerator. What's 5x squared times 2? 10x squared. 1 times x, obviously x. Cool? And then thank you, last chapter, for realizing that that can still simplify, because don't you have x's upstairs and x's downstairs? What does this really simplify to? 10x over 1, which you don't need to. But you know that x can't equal 0, because when you're like putting your money in this pop machine, there's something that just doesn't even fit before you get started. You can't put 0 in this function in the first place. It didn't even work. So it's not eligible for when you manipulate it and try to put it together. It's like 0 didn't work before you got started. It can't work in the future either. It never worked in the first place. Okay? So always do restrictions in your domain before you simplify. And now, for the nightmare, this is the hard part. Got to take f, which is 5x squared, and divide it by 2 over x. We've already taken care of the original restriction in the domain, right? X can't equal 0. Same restriction, right? X still can't equal 0. Totally improper right here. You can't have a fraction inside of a fraction. You've done this back in algebra, but definitely not enough. If you wanted to take 2 and divide it by like 4/5, you instead took 2 and multiplied it by something else to make it actually work out. What do you do to that thing? Multiply by the reciprocal instead. So if you want to take 5x squared and divide it by x over 2, Instead, you could multiply by the reciprocal of 2 over x, which would be what? X over 2. And then make that a fraction, and you multiply them together. You can't divide by a fraction. Instead, multiply by the reciprocal of that fraction. So what does that turn out to be? 5x cubed over 2. But x still can't equal 0 because it didn't work in the first place. So when you combine things together, it's still not even possible to work. Right? It couldn't fit in this thing, so it can't fit in the combination. One more extra example. I got rid of the add, subtract, and multiply because I'm going to probably bet that you have absolutely no problems with this. Turn this packet to the very back where it's blank, and please write this down. Again, I'm pretty confident that you could add those together, you could subtract them from each other, and you could multiply them together. It's the dividing part. Again, the number one thing you should do before you even get started is look for restrictions in the domains before you even attempt to do stuff with them. Red guy, does it have any restrictions in the domain? You are not dividing by any x's. There are no square roots in there either, so everybody works, right? Blue guy, are there any restrictions in that domain? Everybody works. Write them as f over g. X squared plus 7x plus 12 over x plus 3. Problem already happening. When you write it as a fraction, don't you get x's in the denominator of that fraction? So we must go and restrict the domain already. What can't x equal in this problem? -3 makes this 0. And again, if you didn't know that, you just take whatever the denominator is and say, I don't want that to equal 0, and solve for x. You'd subtract 3 from both sides, and x can't equal -3. So there's the restriction in your domain. The part that you won't like is, okay, now I got to simplify this. That top guy can factor. Factor that top guy with your pal. There is no GCF that can come out. This is not a perfect square trinomial because 12 is not a perfect square, but the a value is 1, right? So, two numbers that multiply together to be 12 and add together to be 7. What are those two numbers? 3 and 4. So this guy really factors to be x plus 3 times x plus 4, and it's still over that x plus 3, right? Now look top and bottom. Do you see anything that can cancel out? Boom, boom. That's a real major clue for you when you're trying to simplify this and something can factor. I'll bet you 99 times out of 100 that this has to be one of the two guys that you're going to factor it to, right? It's like the stuff's supposed to cancel out in these problems. So this answer, f over g, is really just x plus 4. Are there any restrictions in the domain, though? X can't equal -3. We originally had a problem right there. He will be in your final answers as a problem. Woo! All right. Now, compositions of functions. See that? Is that a closed dot or is that an open dot? That does not mean multiply. That means take a composition of those things. That's read out loud as f of g of x. You kind of did it in advanced geometry when you did your reflections, translations, and rotations. Some of you haven't gotten there yet, but you did like f following g or anything like this. You'll get to there. But here's what has to happen. This is f following g. Most people say f of g. So let's make a little example. If Freddie is following me down the hallway, right? Me and Freddie are walking down the hallway, and Freddie is following me. Who's in front? Am I in front or is Freddie in front? If Freddie is following me, I'm in front. F follows G. So who really goes first here if F follows G? G has to go first. The second dude that you read is really what has to come first. They want us to find f of g of x right here. What that means is the closest guy to x, the guy on the inside, needs to go in for x into the other function. You take g of x, which is really x minus 6, correct? G of x is x minus 6. And you take x minus 6 and you put it in for x anywhere in this function. So here's what we'll write. We will say f of g of x. You don't need to put the f of g into parentheses. Try not to make it look like the word fog, okay? It should be a smaller little symbol, not F-O-G, right? It's f of g of x. This says fog, okay? See how big I made that circle thing, right? So little tiny guy, f of g of x, let me erase that for a second, equals. All I'm going to do is rewrite this guy right here. But where there's parentheses, I am putting x minus 6 in its place. So x minus 6 squared plus 2. Do you see that where there was an x, right, I put x minus 6 in its place? It's the substitution property. This went in that blue spot right there. Okay? And we'll get better at it. Now, we just need to clean it up a little bit. You don't need to keep bringing this down. Just bring your equal symbol down. This binomial has to get squared. There's a shortcut for that. What do you do? If you want to take x minus 6 and square it, what do I do? Square the first guy. Twice the product. That's cool. At least you know what to do. Maybe you don't know how to say it, right? But you want to take twice the product of these two guys. So you multiply them together, and you get negative 6x. Then take it times 2. How much would that be? Negative 12x. So it is difficult to say. It's twice the product is what you say. And then you square the last guy. What's negative 6 squared, baby? Positive 36. And of course, that plus 2 is still there, right? Then you combine like terms, and you throw it in ye old answer blank. If my pen would have worked. Awesome sauce. They're asking for domain, so we should have looked at the original domains. Aren't original domains totally fine by themselves? This guy has no problem, and this guy has no problem, right? They're all real numbers. There were no x's in the denominator, no square roots. Then look at this. Does he have any problems with him, or does all real numbers work? All real numbers. So in interval notation, that is from negative infinity to infinity. And just for fun, because we're getting kind of out of practice with it, let's write it in set notation also. It is the set of all x. How do you say this up and down thing out loud again? Such that. It's the set of all x such that x is an element of the real number system. Good for you, especially on ACT type stuff, to see that set notation again, because it's been a while. It's a set of all x such that x is an element of the real number system. That was f of g of x. Didn't we put g into f, right? Now check this out. This is g of f of x, completely backwards. Who goes into who? Should g go into f, or should f go into g? F goes into g, right? Reading inside out, if you will. So it's like I start over, and this has to go in for x into that one. Right? F goes into g. So g of f of x equals x squared plus 2 minus 6. This f went into the g function in for x. And since there was really nothing there, it's just 1 times x, those parentheses really didn't even matter. What would this clean up to be? X squared minus 4. Any problems with that for domain? Is there any restrictions in the domain, or does everybody work? Everybody works, right? So negative infinity to positive infinity, set of all x such that x is an element of the real number system. For those of you who don't know what that says, the people that had me, and even I think Mr. Peterson, You made him say it out loud every time. When you write it to yourself, it's the set of all x such that x is an element of the reals. When you write it, say it, it makes it a lot easier to understand. Cool. Let's do another one. Here's f, here's g. Any problems with those restriction-wise for the domain? Any problem with those? Everybody works? What am I doing with this? First of all, do you notice I'm not multiplying them together because that's an open dot, not a closed dot, right? That's f of g of x. Should I put f into g or g into f? Take g and put him into f. And I literally, like, put the parentheses around there and I draw myself a little arrow. It's like, okay, I'm going to take this and put it in wherever there's an x. There's a couple of x's. Here's some x's. Here's some x's. You're going to substitute him in, right? Just take this and put it in parentheses. So f of g of x equals x squared. That is also getting squared plus 3 times x squared plus 1. This went in for x into every one of those positions. Where there was an x, I replaced that with an x squared. Okie dokie. Cleanup time. What's x squared? Squared. X to the fourth plus, this would just be 3x squared plus 1. And there are no like terms, so, oops, x to the fourth plus 3x squared plus 1. Does this have any problems with his domain, or do all reals work? All reals, baby. Negative infinity to infinity, the set of all x's such that x is an element of the real number system. If you struggle with that element symbol, make the letter C and then put a little staff in it right there. That's what you do. Do g of f of x for me. G of f of x. Who goes into who? Does g go into f or does f go into g? Okay. F goes into G. Thanks for answering. So this goes into that. So G of f of x equals x squared plus 3x plus 1. And that's got to get squared. We do not have a trick for this. There probably is one. I don't know it, off the top of my head. But this is not a binomial. That is a trinomial, right? What I showed you was for binomial squareds. That's a trinomial. So when you want to take a trinomial and square it, don't put that. Put that same trinomial again. Squaring things means take it times itself, right? So write it like x squared plus 3x plus 1 and x squared plus 3x plus 1. Trinomial squared, just take this guy times this guy. I'll let you do that on your own. You can pause the video and multiply that out. When you take 3 guys times 3 guys, you should get 9 guys back, because 3 times 3 is 9. And in the like term combining, hopefully we didn't make any exponent mistakes. That's the big whoopsie. And everybody works for him. Composition of functions uses the open dot. Read out loud as following, or of, g of f of x. Next, still a composition, f of g, but this is not an x. It's of a negative 2, right? So that means, like if I just asked you to find g of negative 2, don't you take negative 2, put it in for x, into the g function. So I've got to put negative 2 into one of these guys. Who do you think it goes into? Should it go into f, or should it go into g if f followed g? Who went first? G. First thing you do is find g of negative 2, baby, and you will write it down. You can do a lot of this stuff mentally, though, because it's really not that hard. Or you can even put it in your dang calculator. I don't care, but I want to see what g of negative 2 is. So negative 2's got to go in here into the g function. Wouldn't that give you 4 plus 1, which is how much? 5. Would you agree that g of negative 2 is 5? Cool? You take this result, and now it goes into the next function that they wanted, which was f. So now we will find f of 5. Because you're supposed to find g of negative 2, and that result then goes into the f function. So f of 5, that would be 25. And there's your answer, because you're out of functions. You do this guy first, you work from inside out. And then whatever that guy is, you put him into f, you're out of functions, there's your answer. So let's jump over here. What should I do first? Well, they wrote it a different way. Right? Instead of using the composite symbol right here, they just used parentheses. Yes? So, sorry. When they use parentheses, it's the same way of using a composite. You've been trained. How do you work with parentheses in math? From outside in or from inside out? Inside out. So, here's the 3. 3 has to go into, isn't h the next thing that you work to? 3 has to go in for h. So, let's find h of 3. And I'll do it like this. I'll write each little nugget down. I'm putting 3 in right here. 3 squared is 9. 6 times 3 is 18 plus 8. Right? Then if you need to punch that in, punch it in. It's 9 plus 18 plus 8. You should get 35 when you punch that in. What do you do with this 35? It goes into the next function, which is g. So I want to find g of 35. And here's g. I need to put 35 in for x. So negative 2 times 35 is negative 70. Plus 1 more. Isn't that negative 69 right there? And how do I know I'm done? Because haven't I used up every function possible? I'm done. Negative 69. F of h of negative 3. You need to put negative 3 into which guy first? F or h? H. Do it. Find h of negative 3. H of negative 3. There's h. So I'm going to go one nugget at a time in this. That would be 9 minus 18 plus 8. Because negative 3 squared is still positive 9. Negative 18, 8. Isn't that negative 1? Is that right? Now, I put negative 1 into which function? F. So f of negative 1 equals negative 5. Noise. I want to change problem D. I want to put this in there also. So throw a little parentheses around the whole thing and throw an F outside of it. 3 for 1 special, baby. Start from inside out. You need to take 4 and put it into which function first? Put it into G. So please find G of 4. G of 4, negative 8 plus 1. G of 4 should be negative 7, correct? Now take negative 7 and put it in for the h function. Did you get 15 back when you do that? Is that right? 49 minus 42 plus 8, 15. Now 15 has to go into the f function. So you just keep working until you're out of functions. 5 times 15 would be 50, 20, 75. Is that right? Noise? What I want you to do, you and your pal, do number 6, A, B, C, D. First thing you should do, look at your original functions, see if there's any restrictions in those domains first. Okay? Then do A, B, C, D. Pause the video, check back when you're done. So here's what I got for all you out there in video land. I'm hoping part A, B, and C weren't a problem. Remember, when you subtract, you just got to change all the signs in that second guy. Part D is where we have the mess. One, you introduce x into the denominator, so you have to restrict that x can't equal 4, because negative 4, because if you put that in there, you'd get 0 in the denominator. Top guy can factor, frowny face, since a is not equal to 1. So two numbers that multiply together to be negative 24 and add together to be 5 are these two bad boys right here. 2x squared minus 3x plus 8x minus 12. Factor it up by grouping, and you get x plus 4 and 2x minus 3. Mr. Bottom, that's also the problem that we have. 3 letters, GCF. What's the GCF between a 3x and a 12, baby? 3. Take that out, and you get your x plus 4 left, and peace out to the x plus 4s. 2x minus 3 all over 3 is what it turned out to be. Cool? It is not fun, and it is what calculus, FST, and the rest of this class has a lot to do with, is rational functions simplifying and restricting domains. Cool? All right.